Good morning, physics champion. In few seconds, we will solve together a complete IGCSE Physics Paper 2. During that, I will explain for each question two main points: why we especially choose that answer and why the rest are wrong. So I'm expecting to consume more than the time allowed because of the explanation. Keep in mind, the time allowed for this paper is 45 minutes. The total mark is just 40 marks, and the load of the paper is 30%. To download the revision note and the marking scheme for this paper, and this paper itself, I will put that in the description. Let's get in. Instructions: there are 40 questions on this paper. Answer all questions. For each question, here are 4 possible answers: A, B, C, and D. Choose the one that you consider correct. Follow the instructions on the multiple choice answer sheet. I'm going to show it to you now on the screen. Write in soft pencil. Write your name, center number, and candidate number on the multiple choice answer sheet in the spaces provided, unless someone wrote it for you. Do not use correction fluid. Do not write in any barcodes. You may use a calculator if it's just need. Take the weight of 1 kilogram, consider it's 20 Newton. So it means the acceleration equal 10 meter per second square. The total mark, as we said, is 40 marks. Each correct answer will consider 1 mark. Any rough working should be done on this question paper. It means there is no extra paper could be given, but also it doesn't mean that this work could be corrected. And they said here, any work paper, you need to do it, you can do in this paper, and actually they will correct the answer sheet only, nothing else. Here is the answer sheet. This is how it looks like. I'm gonna see that in front of each question, like question 1, I have 4 possibilities for the answers, like A, B, C, D. You need to just highlight what you consider correct, as you see in the figure. For example, in this question 1, I highlighted B if the answer was B. And even if you want to change your mind, you can erase it and change your mind. Choose the other answer. Let's start. Which instrument is most suitable for measuring the thickness of a single sheet of paper? Actually, ruler, it could measure longer distance. Balance, it's for mass. Meter rule, it's for some distances, but actually it's longer than ruler. So if I have a distance longer than 15 centimeter, the ruler given, I can use the meter rule. But in this case, single sheet, or the thickness single sheet of paper, it's very, very, very smaller than 1 millimeter. So we could consider the answer here, it should be micrometer screw gauge. And depending on that, I'm going to highlight in the answer sheet D. So my answer here is D. Question 2, the diagram show distance time graph for 4 objects. Which graph represent an object moving with an increasing speed? Increasing speed, it means we have an acceleration. For example, A cannot be correct because here the speed, as I can see, the time is passing, but the displacement or the distance still the same. It means the speed here is exactly 0. For B, the time is increasing and the distance is increasing with the same rate. It means the velocity here, or the speed here, is constant. I'm going to write here, the slope, constant. And that means, the velocity is constant. It's not increasing. For question C, in the beginning, the slope has a value, but in the end, the slope has a less or smaller value. So it means, the slope is getting down. It means the velocity is decreasing because the slope represents the velocity when it comes to distance time graph. But in the last graph, which is D, this is the right answer. So I'm going to highlight it because actually initially here we have a slope And finally, we have another bigger slope when it comes to change in y divided by change in x. So the slope is increasing, it means the velocity is increasing, and this is what they ask about. So the right answer here, it's supposed to be D. For question 3, an object has a weight of 6.4 Newton on the Earth, where the gravitational field strength is 10 Newton per kilogram, as they wrote in the cover. Which row states the mass and the weight of the object on Moon, where the gravitational field strength decreased to be 1.6 Newton per kilogram? In such these cases, the mass stays the same, so I'm going to choose the mass. Just find the mass first. The mass of the Moon, or the mass of the body on the Earth, equal to 6.4, which is the weight, divided by the gravity acceleration. It could give you 0.64 kilograms. So I'm going to choose 0.64. This is the mass. So the answer is A or B. But when it comes to the weight should be changed because we are on the Moon. So simply I'm going to choose 1. But there is a calculation behind that. I could say, the weight, which is Fg on the Moon, equal to that mass, which is 0.64, times the acceleration in the Moon, which is 1.6. So the answer, depending on that, is going to be 1. Right? So the weight here, it's supposed to be 1. So depending on that, the right answer here, the common answer here will be A. So A is right and the rest are wrong. In question 4, which substance is in the table has the lowest density? Since density equal mass over volume, and they ask about the lowest density, so I'm going to choose the smallest density ever. It means you need to choose the lowest mass and the highest volume, because in any fraction, if you increase the denominator, the value of the fraction gets reduced. Right? So I'm going to choose the highest volume and the lowest mass. And depending on that, the answer, as you see here, it's supposed to be C. Because actually this is the highest volume on the table, and this is the lowest mass that I have, except if we have 1.2 and 1.5, but still the ratio between 1.2 and 1.5 to 1.8, it's still less than the ratio between 1 to 2. So depending on that, if you do the calculation mass over volume, the answer here will give you the smallest fraction or the smallest density when it comes to mass over volume, or 1.8 divided by 2. Right? I can do that very, very quickly. Like here, the density will be mass over volume. It could be 1.2. Here, 1.5 divided by 1, it gives you 1.5. And the last answer here gives you 1. But 1.8 divided by 2 going to give you 0.6, which is 0.9. So which is exactly less than the rest. So the right answer here is supposed to be C. In question 5, this is related to the turning force. They said a 20 meter long uniform bridge of weight 100 kilonewton, supported at each end by pillars, as you see in the figure. The pillars exerts forces T1 and T2 on the end of the bridge. What are the values of T1 and T2 when a van of weight 24 kilonewton is on the bridge? When the system imbalance, it means we have two conditions. The only conditions that I care about in this question could be, the total force acting down should equal the total force acting up. So depending on that, the total force, T1 plus T2, it's supposed to equal 24 plus 100 kilonewton. So the answer should be 124 kilonewton. So let's see when we add T1 to T2 in each question, what could be the answer. So it's so clearly for me, when I add 68 plus 56, it's going to give you 124. So the answer here could be 124 kilonewton, and this is the correct answer. But if you add the rest, you will get another value for the total forces, and which is wrong. So I'm going to choose C here as a correct answer, because the total T1 plus T2, which both acting up, equal to 124, the total force acting down. In question 6, a spring which obeys Hooke's law, it means we didn't reach to the limit of proportionality or to the elastic limit, has an unstretched length of 10 centimeters. So this is the original length that we have in the question. A load of 20 Newton is suspended from the spring. The new length of the spring is 36. It means if the new length becomes 36, it means the extension equal to 36 minus 10, it can give you 26 centimeter. So that was the extension. So what's the spring constant K? You know, spring constant equal force divided by extension. So depending on that, the force equal to 20 Newton divided by the extension, which is 26. So it could be a little bit smaller than 1. So I'm going to choose B. If you do 20 divided by 26, the answer is 0.77 Newton per centimeter, right? I can expect that using mental math, because when I said 20 divided by 26, it cannot be 0.56 because there is no much difference between 20 and 26. But I can infer that, you know, it's a little bit smaller than 1, so I'm going to choose directly 0.77 without any further calculation. In question 7, what is the relationship between the impulse acting on an object and the change in momentum of the object? I said here, impulse means force times time, and it's going to give you the change in momentum, right? So they are exactly equal. So depending on that, if you memorize the law well, I'm going to choose A. Even in that question, please remember that, you know, change in momentum equal to delta mv divided by time. So it means m delta v divided by time. It means mass times acceleration when it comes to divided by time. So when I say change in momentum divided by time, it gives you the force. And as you see here, the force equal mass times gravity times acceleration, and that was the second law of Newton, right? So depending on this law, if you do cross multiplication, you will reach to that F times time equal to delta P. Delta P here is the change in momentum, right? So, and F times T here is the impulse. So depending on that, the right answer could be A. For question 8, electrical energy may be obtained from nuclear fission. In which order is the energy transfer in this process? Like, all of them start with the nuclear fuel, then generator, or reactor and boiler. I think the right answer here, it's supposed to be, we need to start with the boiler to produce the steam. So the boiler, when it produces the steam with a very high pressure, it could turn the turbine, then it could generate the electricity inside the generator. When the turbine rotates inside the generator. So actually this is what we have here as an answer. So the right answer here is supposed to be D, nuclear fuel. Then it could boil the water. The steam will coming out with a very high pressure to turn the turbines. The turbine will generate the generator to produce electricity. So the right answer, depending on that, is going to be D, and the rest are wrong because of the order of the processes happen. In question 9, a motor of power P exerts a force F on an object. The object moves a distance D during the time T. That's the force act. So which equation is used to calculate the time? Let's do that from the beginning. We know any power, since any power equal energy divided by time, it means any energy equal force times displacement divided by time. So if you rearrange this equation by doing cross multiplication, you will reach to that power times time. It gives you force times displacement. So depending on that, the time could be force times displacement divided by power. So depending on that results that we just reached, it could be Fd divided by P, which is B here. So the right answer here, it's supposed to be B. And the rest have some mistakes when it comes to rearrange the equations. In question 10, a sign test uses an electric motor to lift a load through a vertical distance of 2 meters. So here we have a displacement. So he then increases the input power of the motor and repeats the experiment. The efficiency of the motor does not change. This is a very important point. It means 100% efficiency. So which row correctly describes the effect that this has on the useful work done lifting the load and the time taken to lift it? In such these questions, we have something like, it's 2 meters, this is the vertical distance, and they said he then increased the input power. So when I increase the power of the motor, so the time should be less, because you know power equal force times displacement. This is the energy, could represent the energy divided by time. The only things changed here, we didn't change the displacement, but we did change the power. So when I say the increasing power here and the energy stays the same, when it comes to the energy stays the same, it means, you know, that T should be less. And they said here, you know, there is nothing happening for the efficiency. It means the energy in should equal the energy out. And that means from the law, if you think about it, you know, the time and the power, they are inversely proportional. So by increasing the power, they said increase the power here in the question, it means the time could decrease. But the work, because it's working with 100% efficiency, the energy or the work stays the same. So depending on that, I'm going to choose B for that question. Just keep in mind, you know, power is inversely proportional with the time, just under one condition, if the energy is constant. And that happens if it was working with 100% efficiency. That was question 10. In question 11, 4 containers are filled to the top with the same liquid. The base, when I say the same liquid here, it means the same liquid in density when it comes. So they have the same amount of liquids, and these liquid or the density is constant for all of them. The base of each container is circular. Which container has the greatest pressure exerted by the liquid at its base? If you think about the law, we said pressure equal rho GH. The same liquid, it means the same density, so there is no change in density. Gravity, acceleration, they are all under the effective gravitational field, so we still have H. So the highest H, it means the highest pressure at the bottom. So depending on that, the right answer here will be A. That was 11. Because it's more H, so we gotta choose A. In question 12, a liquid is evaporating. The liquid is not boiling, so it means evaporating in a temperature less than the boiling point. Which statement about the liquid is correct at an instant in time? Any molecules can escape. No, the word any here is wrong. Only the molecules at the surface only can escape. So this is the mistake in A. Any molecules can escape, still the same, any here is wrong. Only the molecule as the surface could escape. Only molecules with enough energy can escape, and only from the liquid surface. I think here we got the answer. Only molecules with enough energy, this is a very realistic word, if the energy enough to escape and to change the state from liquid to gas, and it's supposed to happen at the surface because all molecules at the surface, because they have higher temperature, it means they have lower density, so they're supposed to be on the surface. So depending on that, I have no doubts the answer is C. Let's see what's wrong in D. Only molecules with enough energy can escape, but from any part of the liquid. This is a mistake because the molecules, if they have enough energy, it's supposed to be in the surface or at the top because they have less density. So this word is wrong, or it has no meaning. So the right answer here is supposed to be C. In question 13, the diagram shows two cylinders connected by a narrow tube fitted with tape. So we can open the tape and close it whenever we want. So one cylinder contains 80 centimeter cube of gas at a pressure of 2 times 10 power 5 Pascal. The other cylinder contains a vacuum. So it means I know the cylinder, which is 80 centimeter cube of gas at pressure 2 times 10 power 5 Pascal. The other cylinder contains a vacuum. It means it has a volume, but there is no gas inside it. Anyway, the volume of the evacuated cylinder is 20 centimeter cube, as written in the question. The tab is opened so that the gas can flow to fit both cylinders. The temperature of the gas remains constant. This is a very important point. It means we're going to use part of the law, not all the law. When it comes to PV divided by T, ignore that T because it is constant. What is the new pressure of the gas? Let's find out. Since PV, I mean 1 divided by T1 equal P2 V2 divided by T2. When it comes to the temperature, they said the temperature is constant, so this T will cancel this T because simply they are equal. So I still have this law, pressure 1 times volume 1 should equal pressure 2 times volume 2. Pressure 1, I'll consider it for the first container, which is 2.0 times 10 power 5 Pascal, times the volume of the first container, which is 80 centimeter cube. No need to change it into meter cube because the two sides of the equation should be in the same measuring unit. Equal to the second pressure, which is the unknown. I'm going to give it a symbol, which is, for example, P, times the new volume. Remember, the new volume is not 20. The new volume is supposed to be 100. Right? If you do that, you will find that the pressure equal 2 times 10 power 5 times 80 divided by 100. It means the pressure could reduce by around 20%. So depending on that, if you do that in your calculator, you will reach to the answer and you will write it's around B. So the right answer here, if it's reduced by 20%, it means it's going to be changed from 2 to 1.6. So depending on that, it could be P. And the rest are different numbers. It means they are different or wrong answers. In question 14, an aluminium block has a mass of 200 grams. The specific heat capacity of the aluminium is 900 joule per kilogram dot Kelvin or dot degree Celsius. How much energy is needed to increase the temperature of the block from 20 to 110 degrees Celsius? Remember, we are asking here about the amount of energy, and we give you the specific heat capacity and the mass and the change in temperature. Just remember that law, since the specific heat capacity equal to the energy divided by M delta T. So if you do cross multiplication, it means that Q equal MC delta T. The mass has been given Remember, and this is in kilograms, so the mass is supposed to be in kilograms to avoid any negating in the answers. So the mass here is just 200 grams. It means 200 divided by thousands to change it into kilograms, or you could say times 10 power 3, times the specific heat capacity for the aluminum is 900, times the change in temperature, I'm going to say from 20 to 110, so we have 90 degrees. If you do that calculations in your calculator, you will reach to the answer, which is C. So depending on that, the answer here will be 16,200 joule. Remember, we need to change the mass into kilograms in order to keep the measuring unit in joules. The next question, in question 15, the diagram shows a liquid in glass thermometer. Which change to the design would result in a more sensitive thermometer? We need to increase the sensitivity or make it respond for any very, very small change in temperature. This is what's meant by sensitivity. It's different than responsiveness. Sensitivity here in the question means it could be sense or respond for any very small change in temperature. So let's read them. Increase the density of the liquid. Actually, it has nothing to do with that. The density here is not related. It depends on the expansion of the liquid, not the density. Increase the diameter of the capillary tube. Actually, if I increase the diameter, so the expansion will happen with a very, very small length. It means the sensitivity becomes less. So the change in height here will be less. So this is also wrong. In C, increase the number of scale markings. Actually, there is something happened to the design. If I increase the number of scales without changing the design of the thermometer itself, maybe gonna give you the same results or wrong answers or wrong readings. Increase the volume of the bulb. That's it, because by increasing the volume of the bulb, it means we have more liquid. So once when we have more liquid, so the expansion volume will be more, so the height will increase. So in that case, we can differentiate between very, very small two different numbers when it comes to change in temperature. So the right answer here is supposed to be D, because more liquid, it means more height when it comes to expand. So when I have more height, so the divisions becomes wider. So in this case, the sensitivity becomes more. In question 16, the diagram shows a pan used for cooking food. The question is, which row is correct for the materials used to make the base and the handle of the pan? Let's see. The base of the pan, it's supposed to be good thermal conductor, or poor, it's supposed to be good. So I'm going to choose here A or B. Poor thermal conductor here, it could increase the time of cooking, and this is one of the disadvantages that we need to avoid. In the second column in the table, the handle of the pan, it's supposed to be poor thermal conductor, and this is just for safety, to keep your hands safe. So I'm going to choose the word poor thermal conductor for both. So the common answer here is B. That was an easy question. For question 17, now we start waves. The diagram shows a wave in a Readable tank containing water. So the wave approaches a barrel and passes through the gap in the barrel. The size of the gap is about the same size of the wavelength of the rebels. That's why they looks like wave Wi-Fi signal. So the gap size is increased. When the gap size increased, it means the diffraction becomes less, and it could be a little. The curves here becomes straight or very, very close to be straight line. So let's see what's written here in the answers. The rebels are closer together. Actually, there is no reason for that, Because if they were closer, it means the wavelength change, and the wavelength, it's supposed to be constant. So I'm going to write here the wavelength is constant. That's why this is wrong. B, the rebels are farther apart. Again, the wavelength is constant. That's why it's a wrong answer. The rebels are more curved. No, it's supposed to be less curved, or to becomes a straight line. So here it's more, here is wrong. It's supposed to be less. And depending on that, the right answer is supposed to be D. And it's written here clearly, the rebels are less curved. In question 18, the diagram shows a wave. This is a transverse wave, crest troughs, as you know. So which row correctly indicates the amplitude and the wavelength of the wave? Let's test them one by one. The distance between 1 and 2. The distance between 1 and 2 here, this is the amplitude. I agree with that. I have no doubt it is the amplitude. So I'm going to highlight this one is correct. And I still have the distance between 1 and 2. This is also correct. The distance between 1 and 3. 1 and 3, this is double of the amplitude. So both these two answers are wrong on the left column. In the right column, for the wavelength, the distance between 4 and 5. Between 4 and 5, this is half wavelength. So this is wrong, because actually between 4 and 5, it's going to represent wavelength, but divided by 2. The distance between 4 and 6. 4 and 6, yes. I got one trough and one crest. So this is the wavelength, or one wavelength. It is the length of the wave. So this is correct. The distance between 4 and 5, again, we said it's wrong. The distance between 4 and 6, we said it's correct. So the common correct answer here is B. So I'm going to go to option B and highlight it. For question 19, two beams of light are both the same color of red. One beam is traveling through air and the other beam is traveling through water. Each beam has a different brightness. Which quantity is the same for both sets of wave? I can infer that without reading the question, because actually they said red here. It means the frequency is constant. That's it. The amplitude may be different because of the energy. The speed, I'm sure it is different because we have two different mediums. And once when the speed is different, it means the wavelength should be different. But the frequency stays constant because the color cannot be changed once when I change the medium. So depending on that, I'm going to choose B is my answer. In question 20, the diagram shows a ray of light in air incident on a glass block. Some of the light is refracted and some of the light is reflected. Two angles P and Q are marked on the diagram, as we can see here. Which row gives the angle of incident and state whether total internal reflection occurs? Actually, once when I have some rays get inside the medium of glass, it means there is no total internal reflection here. Because there is a reflection, but it is not totally. So I'm going to highlight here the easy one for me. It's no, there is no total internal reflection. But when it comes to the angle of incident, it is the angle between the normal and the incident ray. So depending on that, I'm going to choose Q. So Q is the angle of incident. So depending on that, the right answer or the correct answer will be C. 50% of the exam. The diagram shows a ray of light in glass incident on the surface between glass and air. What happens if the angle of incident is made larger than the critical angle for the glass? If it was larger than, it's not looks like larger critical angle, but if it was larger than the critical angle, it means the the ray will reflect back to the same medium, which is called total internal reflection. So let's see what we have as an option here. The angle of refraction becomes equal to 90. Actually, it does not compatible with the idea of larger here. If it was equal, I can agree with that, but A, depending on that, will be wrong, because it could be equal if it was, it could be 90 if it was equal to critical angle. So A is not the right option. There is a refraction ray and a ray reflected inside the glass. Yeah, this is yes if it was less, like the previous question. There is a refracted ray only. No, there is no refracted ray at all. There is only a ray reflect inside the glass, and this is what we said. If it was larger, so total internal reflection could happen. So the answer, depending on that, is going to be D. That was for 21. 22, the sun emits infrared radiation and light. Light from the sun reaches the earth in 8 minutes. Which row gives the correct information about the infrared radiations? The wavelength of the infrared radiations longer than the wavelength of light. The time taken for infrared radiation to reach to the earth, is it 8 minutes or less or more? Let's see. Guys, in air, when it comes to air itself, the wavelength could be different because they have the same velocity. I can say that for the red light, the velocity equal to frequency times wavelength. So if we compare it with any other light, like green, for example, the velocity equal also frequency times wavelength. Remember, the velocity is constant for both. So I'm going to write here constant. But for the red, it has a low frequency and higher wavelength. Green, it has a higher frequency comparing by red and lower wavelength, because the green looks like below red on the screen when it comes to diffraction. So this is the idea of constant velocity. So depending on that, if it's constant velocity, it means the red light or whatever the color is could reach to the earth in the same time because it has the same speed. But when it comes to the wavelength for red, the wavelength for color red, it is larger than the wavelength of red, because when you go up, as we mentioned here, the wavelength of red is larger than any other visible light. So I'm going to choose larger here as an answer, or longer, as they said, so longer than the wavelength. This is what we correct answer. So the common answer here is A. I'm going to choose A. For 23, which list shows region of the electromagnetic spectrum in order to increasing frequency? Increasing frequency, I can infer that the highest frequency that we have, when a high frequency here, this is for X-rays and gamma rays. So I'm going to write here X-rays. And when I go up, I could reach with the visible light and infrared and UV before visible light and so on. This is by, and they said increasing frequency. Increasing frequency, it means I'm going to go in that direction. So let's see what we have here. X-rays, ultraviolet, visible light, infrared, this is decreasing, not increasing. It's not compatible with the word increasing here. X-rays, then infrared. Once when I start with X-ray rays here, I'll not accept it, because X-rays here, one of the highest frequencies that we have. So there is no more unless when it comes to gamma rays. And gamma rays is not mentioned even. So the right answer here, let's start with C. Infrared, then visible light, then ultraviolet, then X-rays. This is perfect. D, ultraviolet, then visible light. Here we have a mistake. We need to switch them. And also the infrared need to be switched to become like infrared. It's supposed to be number 1, then visible light, then ultrasound, then X-rays, as it mentioned in C. So the right answer here is C. 24, what is ultrasound? You know, it's a sound, it has a frequency higher than 20,000 hertz. Remember, the visible sound between 20 to 20 kilohertz, this is what we could hear. This is called audible sound. But here we have infrasound, and in that side, higher than 20 kilohertz, this is what we call ultrasound. So let's see. In 24, they said, sound waves that are so loud. Loud here, it's not the answer. Loud means strong, and actually the frequency did not affect the strength of the sound anymore. So the idea is the sound wave that are too high, pitched for humans to hear. Yes, this is right, because it's non-audible and you cannot hear it because it's very high frequency or high-pitched. Sound waves that are too low-pitched, and actually no, too low, it means below 20. This is wrong. Too low here is wrong. So sound waves that are too quiet here, it's again wrong. It depends on the amplitude, not on the frequency. So the right answer is supposed to be D. In question 25, uncharged matter sphere is placed on an insulating support. A positively charged rod is brought close to the shape or to the sphere, but does not touch it. As you see here, this is induction. So how do the charge in the sphere move, and what is now the charge on the sphere? So the movement of the charge, well, let's see. Actually, in such these situations, I need to just draw here the negative charge and the positive charge, because of the repulsion, will escape to the other side. This is what we could have. And as you know, if the sphere over an isolating base, it means the body should stay neutral, because the number of positives still equal to the number of negatives. So the right answer, depending on that, it may be B or D. Let's see. The negative charge move to the right of the sphere. Yes, this is the right answer. And this is also the right answer. But here the positive move closer or move to the left. Also, you know, this is also correct. Positive charge move to the left. This is also correct. But actually, I cannot choose that. Positive charge move to the right of the sphere. That was wrong. So the right answer, depending on that, the common right answer is for B. The negative charge move to the right, and it's still neutral because the number of positives equal to the number of negatives. In 26, in which circuit is the ammeter measuring the flow of charge through the lamp? Well, let's see. The ammeter cannot be connect parallel. The ammeter connect here series, which is right. The ammeter here is parallel, here is parallel. That was an easy question. So I'm going to choose B because all ammeters should connect series, not parallel. 27, a lamp is connected to a cell. Which circuit diagram shows the direction of potential current I and also the direction of the flow of electrons? So you know electrons coming out from a negative pole. So if that was positive and this is negative, so this is the direction of the current and that is the direction of the electrons. Let's choose depending on that. So depending on that, the right answer will be C. You can see that. You know, this is the direction of the electrons, and that is the direction of the current. So the right answer here is C. All other directions are shown wrong. 28. The diagram shows a circuit containing two resistors of resistance 1 and 2 ohms. A voltmeter is connected across the 1 ohm resistor by connecting P to X. The reading on the voltmeter is 6 volts. Fine. B is moved to point Y in the circuit. What is the new reading on the voltmeter? You know, if the reading here was 6 volts for just one, and then I'm going to attach it to be here, so the reading will be changed to be treble. Because actually the resistance will share the potential difference, right? So across one I have 6 volts. It means across this two we have, if we attach another voltmeter, so the reading will be 12. So if I attach the voltmeter, as they said, between the start point, which is that one, to Y, it means I'm going to measure the entire potential difference for the circuit, which is equal to 18. I mean 6 across 1 ohm and 12 across 2 ohms. It means the entire potential difference is 18. So I'm going to choose D depending on that. In question 29, the graph shows the current voltage relationship for a circuit component X. What happens to the resistance of X and what happens to the temperature of X as the voltage increases? So here we have now the temperature, if it was a wire or a thermistor, but anyway, let's think about the idea of the slope first. You know, the slope here represents 1 over R, not R, right? So I can infer from the graph, you know, the slope is increasing. It means 1 over R is increasing. And that means, you know, R itself is decreasing, so the resistance is decreasing. I'm going to choose A or B. This is both decreasing. Now, let's think about the temperature itself. If the temperature is variable, so, I mean, if the resistance is decreasing, it means the temperature is increasing, right? So depending on that, I'm going to choose B or D, right? Because the current becomes more allowed. So if you heat the object, its resistance will increase, but actually the resistance here will decrease. It means the temperature is increasing, which is the opposite, right? So depending on that, I'm going to choose B. The temperature is increasing, so the resistance of X is decreasing, and we can see that the current will flow in a higher rate. In question 30, the diagram shows pairs of circuits containing logic gates. In which diagram does the lower circuit of the pair behave differently? Remember that this is the key words here. Differently from the upper circuit. So let's test them. If that was 1, so the product here is 0. If that was 0, so the product here is 1, or the output here is 1. So here I think it's the same. So 1 for AND, it could be 1. For NAND, it could be 0, and here 0, it's supposed to be 1 here. So they are the same, so the answer is not A. Let's test B. If that was 0, 1, for example, so the product here will be 0. If that 0, 1, so the product here through, and it's supposed to be 1. And 1, when it pass through NAND, it's supposed to be 0. So this is also the same output. So actually, I will not choose B because the product or the output is the same for both. Here, if it was 1, 0, so the product here for OR, it's supposed to be 1. It says that here, 1, 0. So for OR, it's supposed to be 1, and here it could be 0 because this is NOR. Then 0 with AND, it is 0. And when it comes to 0, it could become 1 here as a product. So again, this is the same, so I will not choose C. Let's test that here. 1 0 and here 1 0. 1 0 for AND, it gives you 0 because it's AND. 1 0 for OR, it gives you 1. For NOR, it gives you 0 here. 0, it's supposed to be 1. Yes, they are different. These two are different, so I'm going to choose D. Remember, in such these questions, please mix the two inputs. Don't choose the two inputs to be 0, 0, or 1, 1. It takes time, right? Just mix the two inputs and make one of them 1 and the other is 0. It could guide you to the answer directly. In question 31, in which circuit do both lamps light? Let's see that. In that circuit, the diode block the pathway of the current, so both of them are off. Here it's the same circuit. The diode will block the current when it comes to the current. Here there is no current. Could be blocked, so both are off. In that circuit, the current will go through this way, which is allowed, and also the current will go through this way, which is allowed. So C is the answer, I have no doubt. Here the current won't go through that direction. It will be blocked. So this one will be off, and this one will be on. And in the previous one, both are on. They ask about both. So my answer is C. That was 31. 32, two resistors with resistance R1 and R2 are connected in parallel. The resistance R1 is greater than the resistance R2. What is the resistance of the parallel combination? You know, any parallel two resistances, the value of the product or the value of the results should be smaller than the smallest one. They said here R1 is greater, so my goal is R2. So the product is less than R2. So I'm going to be, it's less than either, both. So I'm going to choose A here. There is no doubts for this. Right? So the answer here should be smaller than the smallest one. Remember, no R parallel is smaller than the smallest one, even if you have 1 ohm and 1 mega ohm connected parallel, so the resistance in total will be less than 1 ohm. In question 33, the metal cases of electrical appliances are connected to an earth wire. Which statement is not correct? The live wire may become loose and touch the metal case. This is 33. If the metal case becomes live, the earth wire conducts the current to the ground. The earth wire needs to have a high resistance. The earthen metal cases helps prevent a person from receiving an electric shock. Actually, all of them correct except C. And they are here about the not correct. Like the live wire becomes loose, so touch the metal case. Yes, this is the idea. And if the metal case becomes live, yes, so the earth wire could help. And D, earthing metal cases helps prevent a person from receiving an electric shock. Yes, so all of them correct except C. So I'm going to choose C because they ask here about something which is not correct. In question 34, what is the function of split ring commutator in the electric motor with a single rotating coil? You know, any split rings to just reverse the direction of the current to keep the motor rotate. So I'm going to choose the answer compatible with that to enable the motor to function with an AC source. You know, this is correct, but the main idea is to just reverse the direction of the current. If it was AC current, so I'm going to change the AC current into DC current when it fed to inside the motor, so the motor could work or to keep rotate, right? This is the idea. So actually, I will not choose A right now. Let's continue the rest of the question. B, to reverse the current in the coil once every revolution. This is also to reverse the current. C, to reverse the current in the coil whenever this plan becomes perpendicular to the magnetic field. Yes, if it was perpendicular to the magnetic field, we need to reverse the current to reverse the direction of the force acting on the coil. Once when you did so, the force, instead of taking the coil up, it will take the coil down and so on to keep the motor rotate. So this is the most correct one, and the rest are part of the correct, but they are not completely correct. So enable the motor to function with an AC source. Actually, this is part of it correct if the motor is AC motor, so we need to reverse the direction of the current every single or every revolution, especially in that position, if it was perpendicular to the magnet, to change the direction of the force acting, to change the direction of the motion, to keep the motor rotate. So depending on that, I'm going to choose C. D, to reverse the current in the coil, never the plan of the parallel. No, parallel here, the direction of the force is still the same when it passes to be parallel between the two poles of magnet. So the right answer here is C. That was 34. 35. Which graph represents an alternating current? You know, this is DC, direct current, and this is also DC. It's the same, but it's a little stable. And this is also purely DC from a battery. The only alternating current here is A, because we have part of the current positive and the other part is negative. It means we have two different directions for the current. That's why it's alternating. So the right answer here is A. Question 36. The diagram shows a horizontal wire in a magnetic field. The horizontal wire is firmly held at each end, not shown, and cannot move. So the wire itself, it's fixed finally, so, and it's stretched, so it couldn't move. The magnets and a holder are on a balance, as you see here. When there is no current in the wire, the reading on the balance is 0.35 grams. It's shown in the figure here. There is a DC current in the wire right now, as shown. What happens to the reading on the balance? It depends on the force. Let's see. So the current looks like dot. So this is viewed from the above. The current is moving down. It means it's moving outside the page. So let me write that down here. This dot means the current is moving outside the page or towards you. If that happens, and I am going to need to use my left hand rule from N to S, then the longer finger towards you, then the force acting on the wire will be up. If the force acting on the wire is up, it means the magnet itself will be pushed down. If the magnet pushed down, it means the reading here will increase. So it's going to be larger than 0.35 grams. So I'm going to choose D here. Remember, you need to apply your left hand from N to S. Let me draw that here. So this is how it looks like when it comes to using the left hand rule. I agree with that figure. It's exactly compatible. So this finger, it signs the direction of the magnetic field lines from N towards S, as you see in the figure. And this direction of current, it means outside the page. So I here is outside the page. And still the force acting up, so this is the force acting in the wire, which act as an action. So if the wire gonna move up, the magnet will move down. So depending on that, the force acting in the magnet, could be down, so the reading will increase because you are pressing over the balance, so the reading will be larger than 0.35 grams. That was 36. In question 37, the nucleus of an americium atom contains 146 neutrons and 95 protons. It decays by emitting an alpha particle. How many neutrons and how many protons remains in the nucleus when this form of americium decays? I'm not sure if I pronounce the name of the element fine or not, but anyway, for this element, if we take alpha out, it means these two numbers will be changed. So that number will be changed to be a number less by 2, and this number could be less by 4, right? So this is the neutrons, and the total number be less than 4, right? They said here the nucleus of an americium atom contains 146 neutrons. So the total becomes less by 4. So this number, the total here, which is plus 95, it could be less by 4. So depending on that, the number of neutrons remaining, the number of neutrons, I'm going to take 2 neutrons out, only in case of alpha, because alpha is 2 protons and 2 neutrons. So 2 neutrons will be out because of alpha. So this number becomes 44. And the number of protons becomes less by 2, so 93. So depending on that, the right answer will be C. So the mass number will be reduced by 4, the number of neutrons reduced by 2, the number of protons reduced by 2, so the right answer here it's supposed to be C. For 38, said here the graph shows how the count rate measured by a radioactive detector placed near a radioactive sample changed with time. So we start with the highest count rate, this is the maximum, then bypassing the time, bypassing the hours, the count rate get decreased. So give that the background count rate is 30 count per minute. What's the half-life of that sample? 30 count per minutes, we need to subtract them in order to find the half-life. So let's go through that. The reading here is exactly 1, 2, 3, 4, 5. So the reading here is 530. So 110, 20, 30, 40, 50. Okay, so now the background is exactly 30. So the reading from the sample is 500. This is without the background. Then when I say divided by 2, it gives you 250. So the reading after one half-life, it becomes 250 plus the background back again, which is 280. So the reading after one half-life, it becomes 280. I'm going to go to 280, which is located somewhere here. So this is 280. And I'm going to go to the graph line. Then I will go down to the time here. So the reading is 3.4, I think. So I'm going to choose 3.4 hour. This is the half-life, which is A. Make sure that you subtract the background radiation in the beginning. Then you need to add it back again because the background radiation is almost constant around its average. Question 39, a teacher holds a radioactive source near a detector. The reading of the detector is 320 counts per minute. The detector is switched on again after the source has been removed. and it shows a reading of 20 count per minute. What's the count per minute slowly due to the source, and why is there is a reading on the detector when there is no radioactive source present? It was answered in the previous one, like the count per minute due to the source. We said just subtract 20, so it's supposed to be 300. And the reason for reading while no source, it's the background radiation. So I'm going to choose background radiation here. So the right answer is B. No doubt it's B. That was easy. The last question, which state or statement is not correct? Remember, all of them right or correct except one. Alpha particles are used to detect cracks in metallic structure. No, it's beta. That was easy. So this is beta to make it correct. So this is wrong one. So depending on that, I'm going to choose A because they ask to choose the wrong one. Let's see the rest. Beta particles are used in the measurements of the thickness of paper. Yes, because it could pass through the paper itself. So we can figure out the density of beta before and the density of beta after the paper. So depending on that, we could figure out what is the thickness of that paper. Gamma rays may be used to treat cancer patients. This is correct. It has ability to kill some cancer cells. Smoke alarms contains a weak source of alpha particles. Yes, this is correct because alpha, it has very small range, so it could be stays inside the equipment or inside the device itself. That was paper 4 for that year. Good luck and have a nice study.